Right. Once we've started sort of thinking about partitioning and the value of numbers, what we'll start to do in year one is starting to think about, okay, what's one more? And we'll use the 100 square a lot, and the children really like the 100 square. And we think about the 100 square as just a great big 100 number line, like the one round the wall, but we've chopped it all up and just stacked it because it doesn't take so much space. Of course, the problem it does give children is that you have to keep going back when you get to the end, but they do get the hang of that. But we will do an awful lot of work on what's one more, and knowing that place value, where numbers are in the number line, means that if we were to say, okay, what's one more than 5, they'll know one more is getting bigger, it's going to be the next one along, so it's going to be 6. And in the same way, what would one less be? So we're doing an awful lot on one more and one less, so they're really comfortable with what that means. And also, sort of building on what Mrs. Burnett was saying, we'll also use our 100 square for, okay, well, what's 10 more? And that's a great visual thing. Children really love this because they can get that 10 more very quickly. Because, oh yeah, it's underneath, it's brilliant, it's fab. But they need to understand that with 10 more, that the units aren't going to change, the tens are going to change. And again, that's very visual. So we'll do lots of work on one more, one less, 10 more, and 10 less. We'll also start thinking about combining numbers as well, and we do that very practically. So lollipops on here, I don't give out lollipops, sorry. We tend to have dinosaurs or counters or things like that. But what we'll do is we will practically count things. So we'll say, okay, well I've got 3 things over here, I've got 1 over here. We're going to count and see how many there are altogether. Now once we've counted those 3, we know there's 3, so we don't need to count them again. So I can continue my counting at 4. So they know, practically they can see that if we push them all together, we've got, a bit enthusiastic, we've got 4 altogether. So we'll do things practically. We don't record these things, we'll just do it practically. So we're watching what they're doing all the time. When we're really comfortable that they've got a sort of a really good practical understanding of that, then we'll start to use what we call a lollipop line. And a lollipop line, or a lollipop number line, is brilliant because it has our numbers on it, but it also has these lollipops at the top, so we can still physically use things. We can use counters on here, and the children can see the numbers still underneath. So if we're combining 3 and 1, we've got our 3 counters, we've got our 1 more, so we've got 4 altogether, they can see the numbers underneath. So that's a brilliant thing to be able to use. Moving on from that, we'd then go to a number line, just a plain number line without the lollipops at the top. But the children now know this is what a number line looks like. We've used it quite a lot with those counters, but now we're getting to the stage where we don't need to do it practically so much anymore, and we can just use the number line. And so we use what we call jumps, and this is where that one-to-one correspondence really comes in. Because if the children don't understand that this is 1 more, this is 1 more, this is 1 more, then they will make errors on the number line. And what children often do, and this is where snakes and ladders and any board games and things like that are brilliant, lots of practice of those sorts of things, so that the children don't go like this, which lots of them do, 1, 2. No, you haven't moved, you can't count it yet. So really important, that one-to-one correspondence, 1, 2. So 3 and 2 more is 5. Then we'd move on to a blank number line, and the children can just draw these number lines themselves. So if we were doing a calculation of 5 and 2, adding 2 or plus 2, on their number line, they might want to draw a 0 at the beginning to make themselves feel comfortable, but they'll have a 5 on the number line, and then they will do just 2 jumps. Or some children will quite happily just do a jump, and that will be 2. And they might add in their own numbers. So what we're trying to get the children to do is to think, I don't always need something that's got the numbers on already, I can do that myself. Now, not all children will go through all of those stages. Some children will miss a stage out, some children will need time on each stage. All children are different. But coming back to what Mrs. Bonetta said about partitioning is really important when it comes to addition of 2-digit numbers. Because what we do is we partition our numbers into those tens and units, so we can add together the tens, we can add together the units. And if the children have got a really good understanding of what the value is of those digits, then they pick that up really quickly. So our 45 becomes 40 and 5, our 33 becomes 30 and 3. So we've just split it up for the moment. Then we can add together our tens, we can add together our units, and then finally we recombine to make a total of 78. Some children need to write all that down. Some children will very quickly be able to do that mentally. Again, all children are different. We also have 100 number lines. I don't have a number line on there. We have 100 number lines, which I'll show you in a minute. I've got one on here and I don't know where I've put it now. Because, of course, sometimes we need to use much bigger numbers. Thank you very much, Mr. Spinner. And the children will often use these, and again, they absolutely adore these because they think, fab, it's got numbers all the way up to 100, it's fantastic to use. And they can use this to find the two numbers on here. I've drawn one up and I don't know where it's gone. Never mind, anyway. Really annoying. So if they wanted to add together, let's say, for example, 68 and 22, they'd find their 68 on the 100 number line. They'd count 10 more, because of course we've been doing lots on 10 more. Then they'd find another 10 more, and then they would count on the units and mark it on their 100 number line. So again, using that partitioning. And when they're really good at that, if they turn their number line over, we've got a lovely blank one. No numbers on it, because they don't need the numbers on there now. So we use those a lot as well. Right. Blank number lines. If we're doing 45 and 33, two ways that the children might tackle this. And it depends really if they want to partition the number or not. What children might do is say, okay, well, I'm adding 45 and 33. I'm going to put 45 on my number line. I know that 33 is 30, so I'm going to add on 3 tens. 1, 2, 3 tens. Each of these is 10. Or they might think, oh, I'm adding 3 tens. I'm adding 30. And straight away be able to put in that it's 75. And then they'd add on the units. Plus 1, plus 1, plus 1. Or they might do a jump of 3. Alternatively, there's no right or wrong way. Children find their own way. They may decide to do 40, and I'm going to add my 30. Sorry, I've written that in the wrong place. Going to add my 30 there, so that's 70, and then they'd add the units on. Doesn't matter which way they do it, it does fortunately end up with the same total. Children may be comfortable with putting 45 at the beginning of their line. And then when we come on to addition of hundreds, exactly the same. Children partition into hundreds, into tens, into units. They'll add together the hundreds, add together the tens, add together the units, recombine it. So in exactly the same way as they did for the 2-digit numbers, they'll apply that to 3-digit numbers, and of course, from there on, you can continue to apply that knowledge. With the number lines, you do exactly the same thing. The children would have 427. And think, right, I'm going to add on my hundreds first. They might do a giant 100 jump if they're comfortable, or they may decide I'm only comfortable with doing 100 jumps, so each one is going to be 100, and then they can say 527, 627, 727, and then they'd continue with the tens and with the units. And then the final one that I've had to really read up on, because I'm only in year 1. So I saw this and I thought, no! Vertical calculation. So we do get to a position where the children will start to do vertical calculation. We don't call these columns. as we did when I was at school, a very long time ago. But we do still, of course, term it as our units or our ones. We've got our tens, we've got our hundreds. And what we will do, first of all, we will calculate the total of the ones or the units. So it's 11, so we must make sure, of course, that we are writing things in the right position. So our 11 is 1 10 and 1 unit. Then we'll add together our tens, so we've got 90 and 60 being 150, and the children, of course, will by this time be very, very comfortable about knowing that 0 is a placeholder. Very important that you've got that there. If you don't, it means something completely different. And then finally they'll add together the hundreds, and then we can combine all of those together to give us our total. So you can really see how that partitioning and understanding the place value is absolutely fundamental to the children's understanding for addition. Let's look at that.
I think the major difference